My name is Leslie Klein. I am the president and CEO of SATCOM Satellite Systems. I started the company 24 years ago. We went public 2 or 3 years later. The company has had a very good run. It has developed a very unique technology. By my background, I'm an electrical engineer. I have an MBA and a PhD. Prior to starting SATCOM, I worked with companies like Bell Northern Research, Northern Telecom, Hewlett Packard, Control Data, IBM, and Digital Equipment Corporation. Some of the old names from the industry. And my last effort here is to get SATCOM on the next level of the technology, which is building the phased array electronically steered antenna to make it possible for the next generation satellites to be connected relatively easily and inexpensively over these phased array antennas that we are developing. SATCOM Satellite System is an Ottawa, Canada-based technology company focused on research and development and design and manufacturing of satellite antennas for communication on the pause. The company was started 24 years ago. It has 34 employees. It is publicly traded on the Toronto Venture Exchange and on the New York over-the-counter QB under the symbol CYSNF. The company has been successful in a sense that it has had many consecutive years of profitability. It pays dividends and it has no debt. The company sells their products through resellers in 106 countries. Over 8,500 antenna systems have been deployed in over 106 countries through about 500 active dealer reseller partners. The products that we manufacture are all compatible with pretty much all of the modems manufactured by modem manufacturers and are deployed on a large number of satellites around the world. The company has over $23 million of working capital. It has paid out over $16 million in dividends and had 40 consecutive quarterly dividends paid with zero debt. The vertical markets that the company is addressing are numerous, and they're listed here, such as governments, military, emergency response, cellular backhaul, oil and gas, mobile banks, broadcasters, hospitals, schools, minings, and many, many other events. The map that you are seeing displays the number of antennas the company has sold and deployed. Not all of them are listed here, but you can see that there is an extensive number of antenna deployments in North America and Europe, and quite a large number of them in Australia and New Zealand, where every fire station is equipped with one of our antennas for disaster management due to fires and earthquakes that are prevalent in that part of the world. This is a lineup of antennas that we manufacture. They are broken down into driveaways, flyaways, and fixed motorized antennas. The driveaways are antennas that sit on top of a vehicle. You press a button and the antenna robotically opens. Within 2 minutes, finds the satellite and delivers high-speed broadband connectivity inside the vehicle. These are on-the-pause antennas, which means you have to stop, push a button, connect to the satellite, do your business, push a button, and the antenna closes, and then you can drive away. The flyaways are based on tripods and transportable cases. They come apart without any tools, and they can be assembled without any tools within a few minutes. And they can be very easily transported either in these transportable cases, or some larger antennas have larger transportable cases for helicopter flights and other transportable opportunities. The latest development in these flyaways is the Manpack, which is shown as the last one on this slide here on the right-hand side. And there'll be some more about that on the following slides. The fixed mobile antennas are antennas that are really VSAT antennas that are permanently located on the ground, but they make it possible to move in azimuth and elevation. And in cases where these antennas are deployed, the idea is that you don't need to send a technician out should there be a misalignment of these antennas to the satellite, because you can just press a button on the controller that is shown on the right-hand side, and this antenna will automatically realign itself to the position it's supposed to be to communicate with the satellite. The controllers that we manufacture are one of the most advanced in the world. They're essentially one-button controllers, so anybody can operate them, and you don't have to be a satellite engineer to align an antenna with a satellite. You can do it with a press of a button, and the controller is integrated with over 20 different modems as a plug and play, and it has 7 different ways of finding the satellite. So the Manpack is the latest development of our engineering team that has developed this antenna. It's a very light, under 20-some kilos, and has a single one-button find satellite controller also. It fits all into a backpack that can be assembled within a few minutes without any tools. It is IP66 rated, so it can be easily left outside in the rain and the snow. It has a one-button solution. It supports multiple bands like KU, KA, and X. And it uses a very high precision carbon fiber pedal reflector. The whole antenna is about 22 or 23 kilos. It can support multiple BUCs, and it's very easy to operate by pressing a simple single button. The antenna will automatically find the satellite within 30 seconds and deliver high-speed internet connectivity. It has been deployed very heavily in Japan following Typhoon 19. As you can see here on this picture, a person is carrying it into the field, and on the left side, it's connected to the power source and to a GSM antenna for cellular backhaul purposes. The antenna is very popular. We have sold over 220 of these units, both for cellular backhaul and also for television stations for transmission of television programs and for transmissions of live events. It's very easy to put together, very easy to take apart. It's easy to carry and can be deployed rapidly in the field. The vertical markets that the company addresses are numerous, and I mentioned those before. You can see them here. I will go through them fairly fast so that you can see the vertical markets and the deployments: oil and gas, satellite news gathering around the world from Belgium to Angola. We have emergency response, fire departments, police command vehicles from China to Japan, and also for cellular backhaul for disaster recovery by SoftBank in Japan. TeleHealth is fairly large number of systems have been deployed for ambulances, for breast cancer screening units, and also recently Walgreens has deployed an antenna system as a mobile COVID vaccination clinic. The military is a fairly large user, although the antennas are not military spec designed. They are used heavily by the militaries of NATO forces, Russian, Chinese, US forces. They're used for very rapid communication because they're reliable, they are easy to transport, and can be rapidly deployed by anybody without knowing anything about satellites. Telecom, of course, is a very large market from places like Fiji, UK, Canada, US, China, Malaysia. They are used very heavily for cellular backhaul and also for promoting cell phones and other services that cellular companies are trying to deploy in very remote areas where there is no easy connection available, but they want to promote their services in those locations. The other very large market is mobile offices. We have antennas in places like South Africa. Over 110 antennas have been deployed there for pension check program. A similar situation in Argentina for printing of passports and IDs, and many other vertical market for mobile office applications such as tax offices, youth services, etc. Mobile banking is another vertical market. We have in South Africa mobile vehicles that are used to refill cell phones. They're not carrying any cash, but we have others that are mobile ATM machines in Germany and in Hawaii and in Barcelona that travel the city and dispenses cash for 24 hours, 7 days a week. So the next generation of antenna systems that we are developing is all based around the golden age of the satellite business that has become very, very hot in terms of new constellations going up. OneWeb will have over 6,000 satellites deployed. They have already deployed quite a few of them. SpaceX has over 1,000 already deployed. They will have more than 3,000 or 4,000. And Amazon Kuiper, that is also getting into the satellite business, is going to deploy over 3,000 satellites. So Telesat, VSAT, Hughes, and many others are all entering this market. And these will be low Earth orbit satellites that will require a totally different antenna system to be deployed on the ground to track these satellites. And so SATCOM, about 4.5 years ago, decided to enter this market with the help of the Canadian government, who funded half of the development, and the University of Waterloo to develop the next generation electronically steered phased array antennas that will make it possible to track these low Earth orbit satellites in Ka-band. So the antenna that you can see here is the size of a quarter, a Canadian quarter, is a 4x4 element. It's based on a Ka-band phased array technology that is Lego-like, which means that you can combine these 4x4 elements and build a larger antenna, and you can build as large or as small an antenna as required. The antennas themselves are able to do electronic beam steering. They can optimize the beam. They can electronically scan 360 degrees. They are scalable and conformal, and at a dramatic cost reduction level, where one antenna consists of several thousand chips, and a few hundred antennas could reach a volume of millions of chips. So the overall cost of the antenna is basically in the cost of the integrated circuits that are building up this antenna system. So the more of these antenna systems, the more of these ICs are manufactured, the lower the cost of these will be over time, and hopefully they will reach a very large scale where the overall cost of the antenna will be relatively inexpensive. So this is a process of how one builds an antenna system from a small 4x4 array up to an 80x80 array. That would be equivalent to a 75 centimeter Ka-band and a parabolic antenna system in terms of performance. SATCOM has also filed a number of patents. One of them is for a based copolar on a coplanar waveguide combined with a dielectric slab, which is actually a phase shifter that makes it possible to shift the signal at a relatively low cost and relatively low power. So this technology has been patented, and hopefully it will be used for the production of antennas with these passive transducers. The flat panel antenna is shown here as an example during testing, besides a parabolic antenna that you can see here. As you can see, the difference between a large parabolic antenna and a small thin phased array antenna between transmit and receive panels is significant. And this is the technology that will be in the future used very heavily to track and follow LEO satellites that are moving, while the antenna systems installed on vehicles, boats, trains, buses will also be moving. So it will not be possible, for example, to use parabolic antennas for these low Earth orbit antenna satellites that are no longer stationary. And so this is what a car would look like with a phased array antenna on top of it. This is what a train would look like with a phased array antenna on top of it. And this is what an aircraft would look like with a conformal phased array antenna on top of the fuselage. SATCOM has also is involved in a wireless communication of the V-band section of the 37 to 48 gigahertz millimeter wave technology with a consortium called the HEFPA consortium that is building a solution to deliver cellular traffic from drones down to the ground by replacing cell towers. And there will be also communication between the drone and a satellite using antennas similar to the phased array antennas that we are developing. And this technology is designed to replace cell towers in a radius of 300 kilometers, where these drones will be flying in the stratosphere at 20-kilometer height, and up to 300 to 400 cell towers would be replaceable with this type of a solution. So telcos delivering cellular services are very interested in this, because this solution would eliminate the requirement of cell towers to be built in areas where it's not economical to put cell towers in. So the partners of this project are SATCOM, two Canadian universities, University of Waterloo and Carleton University. And then there's two manufacturers of semiconductor manufacturers. One of them is NXP and the other one is Skyworks from Canada, that is also based in the United States. So the countries involved are Canada and the Netherlands. So this technology will be delivering 5G plus 6G type solutions at 100 times more bandwidth than it is possible today, and because of the much higher frequency range called the V-band. And the whole concept of it is shown here on this slide that has been pioneered by SoftBank. And there's a link here if you want to look at it to see how these flying drones are able to deliver cellular communication down to the ground by eliminating cell towers. So this is my presentation. There is my email address and our website. Please feel free to contact me and also check out more pictures and more information on our website. And thank you very much for your attention.